Hello guys, welcome to Null Void. Today we're going to go over a problem called lowest common ancestor of a binary search tree. It's a problem being asked in Amazon, Microsoft and LinkedIn interviews, so let's look into it. So the problem description says that given a binary search tree, find the lowest common ancestor of two given nodes in the BST. According to definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node T that has both P and Q as descendants, where we allow a node to be descendant of itself. Okay, let's look at the first example. In this tree, we need to find the LCA of 2 and 8. LCA is lowest common ancestor. So the LCA of 2 and 8 is 6. This is a very straightforward example. Let's say the P equals to 3 and Q equals to 9. Then the lowest common ancestor is still 6. And let's take another example where P equals to 0 and Q equals to 5. In that case, the LCA is 2. Let's look at example number 2. Here P equals to 2 and Q equals to 4. And in the problem statement, we have said that a node can be descendant of itself. So that is why we return 2 for this example. So this looks tough, but it's very simple if you know how recursion works. So how to solve this? The strategy is we go to a node, we then check if the value of P is greater than our current value or less than our current value. Let's say P is less than our current node. Then we say, is Q greater than or less than? Let's say Q is also less than. Then that means both P and Q are in my left subtree, so I can't be the least common ancestor. Same with the case where both are there in the right subtree, where value of both P and Q is greater than node, then I can't be the parent because someone in my right tree is the lowest common ancestor. And let's say there comes a condition. Let's take one example of let's say 9 and 7. P is 7 and Q is 9. We check at node 6. Is 7 greater than 6? Yes. Is 9 greater than 6? Yes. We go to the right subtree. We go to 8. Is 7 greater than 8? No, it's not. So that means it's on my left. And is 9 greater than 8? Yes, it is. So when there is a split, when P, basically when either P or Q is on left hand side and the other is on right hand side, that means this is the lowest, this is the lowest common ancestor. So we can do this with recursion, where at each node we are asking this question, is it to my left or is it to my right? If both are in my left, we will do recursion on the left child of our current node. If both are in right, we will do recursion on the right child, like we did in our example. And the breaking condition will be when one of them is on my left and the other is on my right, then we'll break. So the solution will look like, let me expand this. Yep. So the solution will look like, where at first we will check if P dot val is less than root dot val and then 2 dot val is less than root dot val. If this is true, then that means P and Q both are in my left subtree. So I need to call this recursive function on the left child of root. So we will call this function lowest common ancestor on what? On root dot left, and we can simply pass P and Q. Next condition. Else if P dot val is greater than root dot val and then 2 dot val is greater than root dot val. Both are greater than root, then that means they are on the right side of our current node. So what we need to do is we need to call this function lowest common ancestor on root dot right. Also, this is how the tree, I should have told this before, this is how the tree node data structure is. It has value, it has tree node left, a tree node right, and so when I say root dot right, it's another tree node object, and p and q are also tree node object. It's a simple data structure, and we can pass p and q. Else, if that is not the case, that means uh, they both the p and q values are not on in the left subtree, and neither in the left subtree nor in the right subtree. Then that means one is in left and one is in right. In that case, we can just return root, because this is the lowest common ancestor. Let's run it. For clarity, yes, it works. For clarity, I'll walk you through this again, and you can look at this function and see how it works. Let's say again take an example of, let's say, 0 and 5. So p is 0, q is 5. So we see both of them have value less than our current root, less than our 6. So we go to the left subtree. We again go to this function, 0 and 5. Then we check for now root dot left is 2. We check for 2. 1 is less than, p is less than our current root, and q is greater than our current root. Then that means root is our lowest common ancestor, so we return it. We return from here, that means it reaches this else condition. Root is returned here, which we are again returning back. So that is how we get a solution. Let's submit it. Yes, it works. So that is how you solve lowest common ancestor problem in Java. If you have any doubt in this problem, or if you want me to solve any other Leetcode problem or any other coding problem, you can comment that below. And if you found this helpful, then give a thumbs up, leave a just subscribe to my channel, and I'll see you next time.